Hello everyone, thank you for coming along today. My name is Jonathan Giles. I'm going to be talking about hacking the table view control. Hacking might be a slightly strong term. What I probably should have said is hacking with the table view. I'm a JavaFX UI controls technical lead, so my job is focusing on all of the UI controls that we ship. Specifically, I develop a number of them, one of which is the table view control. If you want to reach me, you can reach me at jonathan.giles@oracle.com, or I like to use Twitter, so you can find me at Jonathan Giles. Before we start, I'd be interested to know where people are at with TableView. The people, if you could show your hands if you haven't even used TableView or if you're very new to it, that would kind of inform me how much time. Okay, so we're all pretty new to it, so I'll spend more time on the intro sections. As per usual, don't buy the TableView control or any component of JavaFX based on what I'm going to tell you today. So what I wanted to do was a brief introduction to TableView control. I might make that a slightly bit longer, and I'm going to have a Q&A session at the end, but I'm really going to try to run this as a BOF. So if you've got questions, feel free to shout them out. I might ask you to wait till the end, so please don't be offended by that. TableView is a control which I built, and it has a lot of power in it, but it's not necessarily clear to people just by looking at the API what some of the API does. So I want to talk about some of the hidden public API. Then I want to talk about some hacks that I've done that we can use. And if there's time, I'm happy to answer as many questions as there are. One other note, I'm a Kiwi, sorry for the accent. Hopefully I don't talk too quickly. If I am talking too quickly, tell me to slow down. I will not be offended by that. My wife tells me to slow down all the time. So how would you summarize what a table view control is? For one, I like to say it's got support for infinite rows. And that's kind of a marketing term, but what I'm trying to say is it doesn't create a node for every single row of data in your observable list. What it does is create the rows just for the visible area of your table view. And as the content scrolls up and the top content goes out of view, it's now reused at the bottom of your table view. So it's exceedingly efficient in that direction. But however, when we designed it, it was designed for a small number of columns. And basically the reason is because even though we virtualize in one direction, we don't virtualize in the other direction. Although, if anyone's interested, I just did, sure.
By column, single digit, double digit?
If you're going over 30, you're going to start having a bit of pain. But like I said, there's ways that I've done to virtualize in that direction as well, so you can have theoretically infinite table columns as well. So like I said, it's fast. We only have the cells for the visible area. And we virtualize them so they're exceedingly efficient. The table view is also stylable in basically every direction you want to style it. You can style just a single cell, an entire row, an entire column, or the column headers. It's all stylable via CSS. And that's how we style the table view control that we ship in JavaFX. It's all done via our Caspian CSS file. And finally, as the API developer of the table view control, I think it is exceedingly better to use than the JTable control. But I may somehow be biased on that. All right, and I warned people on Twitter a few weeks ago, this presentation is by far the most arrow-heavy presentation I've done. So if you like arrows, you're in for a treat. This is a table view. It consists of two columns, a first name column and a last name column. And we're going to work through how this table view was built. First of all, kind of behind the scenes, the way the table view is structured is that you define table columns. But it's the table column that actually also specifies how the data is retrieved. So unlike Swing, where you have a table model and the table model asks you to return a value for a row column index, the table view has table columns, and the table column for the first name column has to know how to get the first name out of the data model. So we're dealing with person objects here. So the first name column has to know how to get the first name property out of the person object. Each table view, basically, in the visible area has a table row associated with it. And each table row has one table cell for each table column that exists. And so, not only is the table column responsible for getting the data and bringing it to the user, but it's also responsible for rendering the data. So each table cell for a column is created by that table column. And we'll go into this in a lot more depth shortly. And so, in short, a table view consists of zero or more table columns, and they visualize a list of items. So what I wanted to show here was basically On the left-hand side, we've got a person class that has two properties, the first name property and the last name property. And I've kind of implied there that there's a getter, a setter, and a property method. And if you aren't familiar with what the property method is, in JavaFX we've got this extended Java Beans pattern where you have, for example, first name property as a method. And basically that will return the string property that you see there. And the reason why we do this is so that you can do all your nice binding that we do behind the scenes. And on the right-hand side, we have what we want to finally end up with, which is that TableView from earlier on. So of course, the TableView doesn't want to deal with just a single person object. It wants to deal with an observable list of person objects. And so TableView it doesn't use an advanced data structure for the table model. It just uses observable list. And the reason why we do this is basically so that we get a whole bunch of stuff happening for you for free. So if you've got an observable list of person, and this person list changes, for example, you add new people, or you remove people, or you reorder the people, the TableView is going to automatically bind to that list for you, so that it will automatically update visually for you. And what I'm doing here is I'm just being a bit lazy. I'm just creating an observable array list with no data in it. The next thing we do is we start creating our table column. So we're going to create a table column for the first name and a table column for the last name. To get the data into the table view, we basically call the setItems method. And the setItems method just takes an observable list of the type of your table view. And you end up with what you see on the right-hand side. That's pretty much a summary of how you populate a table view with columns and data. So if we were to dive into a bit of code now, first line of code there basically is creating a new instance of a table view. The one generic type that you see there is specifying the type of the items list that will be set inside the TableView control. And it's always nice to use the generics if you can, because it makes the code completion a lot easier. Then we start defining our table columns, and there's two generic types here. The first generic type is of the type of the table view that the column is going to go into, so it's person. And this first name column is going to be dealing with strings. You see on the right-hand side there, we're passing in the string first name. That's just specifying what will be seen at the top of your table column. So it's just a pretty string, and it's just a shortcut. You can do that as a separate operation if you want. The second line is something I'm going to dive into a bit later on. But basically what it's saying is, for this first name column, you have to go get the first name property out of the person objects that this table view is visualizing. And we do exactly the same thing for the last name column. Everywhere that we had first last time, we now have last. And then with the table view, we get the columns, and the columns is just an observable list, and this is a pattern that we use throughout the JavaFX API. We return an observable list that you can then change. So in this case, we get the columns list, and we add in the first name column and the last name column. And then in this case, I'm setting the items to be a collection of 3 person objects. And the end result is what we've seen a number of times already. It's a table view with 2 table columns and 3 rows of data. And each column knows how to get the first name and the last name. So congratulations. Sorry, pushed the wrong button. You guys get a short preview of what's coming up. So congratulations, you now know everything you need to know about the table view control. We can all go home. Except, of course, like I said, there's plenty more that we can talk about. So I thought I'll just stop now in case there's any questions about the first part.
So you created the 2 columns, but it looks like there's a third little itty column on the right-hand side.
Okay, so this is a question I get very, very often. This is not a column. This is an absence of any other actual column. So this is just an empty area where we continue the alternate row highlighting. And it is by far the most highly asked question I ever receive. And I will one day just get rid of that alternate row highlighting. But like I say, that is not a column. That's the absence of an actual column. So, any other questions?
Just, is there any column resizing model or something like we have in Suite where you can, make the columns big?
Sure. So there's what's known as a column resize. Oh, to rephrase a question, is there any column resizing policy to specify what the column width should be? And the answer is yes. There's 2 predefined with TableView. There's a constrained resize policy and an unconstrained resize policy. The constrained resize policy always makes all the columns that are visible to equal the width of the table column. The table view. and the unconstrained one just lets them be whatever width they need to be, whether it's wider than the table view or shorter, which is when you get the empty, non-existent table column. Yes?
Will you be going over multiple row column headers today?
This is part of the hidden public API that I'll be getting onto very shortly.
If you're set up your POJO, you're filling your table with, doesn't implement string properties, doesn't use string properties, it just uses strings. What more do you have to do to get those things?
Right, so the question is, if you don't have a POJO that has string property or a JavaFX property, what can you do? And I'll cover that shortly. Yes?
What if you don't have a POJO? What if you just like an array list?
All right, so in terms, so basically, the way we do it at the moment is we've got a property value factory, which I'll cover shortly. One thing I'm not going to cover is we also support maps. So you can put a map in, and as long as you can tell each table column where to get the data from for a row. So if, say you've got a list of maps, and each item in the list is a row. So we have a map value factory, just like I'm going to talk about a bit later on, the property value factory. Yes?
You said that the table model was the same as the data model, so
Right.
observable list, so that when you rearrange items to a list,
Right.
Things get updated in the GUI. But this means you cannot have two separate models then, like one that is displayed that you can reorder and one that just keeps your data in,
Right.
in its default order.
So the question was, because we use the data model as the visual model, that doesn't let you have separate models. And the answer to that really is in JavaFX 2.0, when we released that, the intention was to have, like in glazed lists, if you're familiar with glazed lists, you have a sorted list and a filtered list, and you kind of wrap these things. The intention was to go down that path, except people started poking holes in the implementation of those classes. So we haven't gone down that path yet, but it's still in the works and might be for 8. In those situations, you can start, having mirrored collections and things like that, but we haven't gone a long way down there. And certainly, it's not my job. I'm the high-level visuals. Someone else is the low-level data collections. Yes.
So I'm kind of new to the observable and how it updates the table model and that kind of approach. But I'm curious, when you move things around in the list, observable list, does it actually change the order of the table? And the same with when you change the sorting order of the table, does it change the order of the table?
So basically, the question is, if you change the observable list around, does it change the view? And if you change the sort order, and that impacts the visual state, does it change the collection? And the answer is yes to both. So there's a one-to-one mapping. And certainly, I've got a big thing on my to-do list sometime in the future to make sorting even better for that situation where we don't want to change the underlying data list. And it might be this glazed list approach I was talking about, where we wrap a normal list with a sorted list. And so the sorted list is changing, but the underlying list doesn't change. If you don't mind, I'll carry on. Sure. Right. So there's 4 things I wanted to quickly talk about. And they're the property value factory that I alluded to earlier on, cell factories, nested columns, and multi-column sorting. So, a thing that trips people up is that there's 2 properties of table column that are named very similarly. There's the cell factory and the cell value factory. So the first thing I wanted to do is just clarify what they each mean. And the most important one of the 2 is the cell value factory, because that tells the table column what the data is that it needs to retrieve. So when it's given a person object, the cell value factory is the thing that's extracting out the first name value from that person object. You can, if you want, also give a cell factory. And the cell factory is responsible for altering how that data is presented to the user. So table column doesn't have a default cell value factory. If you don't give a cell value factory, you're not going to see anything in that column. It does have a default cell factory. Basically, it's just going to call toString on your node or on the object and present that as a label. So this is the short form I showed earlier on. And basically what this code is saying is there's this nice property value factory. And the reason why I've created it is so that you don't have to write that every time you want to specify the cell value factory inside a table column. So the first bit of code there with the property value factory, what we're basically saying is find the first name property or the getter on the person object and return me that. So in the case of a person object, if we can find a method called first name property, this property value factory is going to give me back that inside the table view. And if it can't find the first name property, it's going to return get first name. And it's just a string, so it's not going to do anything special. The nice thing about returning the first name property method is that the table view is going to bind to that first name property. So if you've all of a sudden got a table view with a first name and a last name, and you rename one of your persons from Tom to Jerry, that name is going to automatically change from Tom to Jerry on the screen without you having to set up any bindings. If we can't find the first name property method and we have to return the get first name, that's just a string, and so there's no point in binding to that because we're not going to get notified of when Tom is renamed to Jerry. The second approach is basically exactly the same. You can see what's going on behind the scenes, minus a lot of reflection. So the downside of the first approach is technically it might be a little bit slower. I haven't had a chance to measure the performance quite yet, but if you want really high performance, go for the bottom approach, but I would doubt that anyone's going to notice it. And so you can see in that bottom bit of code there, you can see what is actually happening behind the scenes. The P is just a cell data features object, and that basically encapsulates the table view, the table column, and the value for the row that's being rendered. And then so you return the value, and in this case it's the person object. And then the person object, we're just going to return the first name property so we can automatically bind to it. Tom had a question?
Yeah, you're creating bindings showing your text field, for example, and the note to clean up the bindings.
Right. So as we scroll up, and all right. So the question was, we're creating all these bindings. Isn't that going to cost a lot of memory or trouble? And the answer is basically we only create the bindings for the visual area, and as things scroll out of view, the bindings are released, and we put new bindings on the things that are in the visual area. And if you don't want to be bound to, don't return a property, basically. If you are wanting to do the bottom approach, but you don't have a property, because you have to return a observable value, basically you wrap your string, for example, your first name, in a read-only object property. So it's a bit of a ugly thing to do. So ideally, you would use either the first approach there, or you would have properties inside your Java beans. So now that we've covered cell value factories, the next half is cell factories. And they let you customize the visual representation of the data. So some examples are shown in a progress bar if you've got a download application between 0 and 100%, for example. Having a text field when the user double clicks on a cell, those kind of things. And there's two kinds of cell factory in the table view, that is. There's the row factory on the table view, and there's a cell factory on the table column. I'm certain that 999 times out of 1,000, you're not going to use the row factory. By far and large, you use the cell factory on the table column, because basically what you're doing with the cell factory on the table column is specifying the rendering for one single column in your table view. The first approach, the row factory on the table view, is specifying the rendering for a single row. And so that brings with it all the responsibilities of having to lay out the cells for all the columns in that row.
Could you use a combination of two and use a row factor as a one-off if you had a special situation?
No, not really. So the question was, would you use a row factory in a special situation? You try not to, because with the row factory comes a responsibility of laying out all the cells. And that's, there's a big responsibility to have the cells match the headers. And this is going into the implementation, but the headers are separate from the actual cells inside the table view area. So you've got to size them properly, and you've got to lay them out in the right order and all that. So really, if you're wanting to customize on a row-by-row basis, there's probably better options. And that's probably to do with having the right cell factories on the table column. So the intent of cell factories, even though there's a slightly scary API, is that anybody should be able to do it for your specific use case. So the goal is to make it easy and powerful once you get over the API. And the way to do it for a table view, if you're going to do it on a table column by table column basis, is to extend from the table cell class. And the one method you want to get to know is the update item method. And that takes two arguments, the item itself, and the T is a type of that column. So for example, the first name and the last name columns, the T would be a string, and whether it's empty or not. And when we say empty, what we're basically meaning is that we've got to the end of the data and there's no more data to show. So for example, hover highlight shouldn't work on empty cells. And so this is a really good time for you to be told the item's changed, time to update the rendering. So for example, change the text of the label, or perhaps change entirely. For example, if the editing state has become true since the last time that this was called, now would be a good time to start showing, for example, a text field and take out the label. So a cell is basically a label, and so it has a text and a graphic. And when we say graphic, almost always we mean a node or a scene graph in its own right. So when you set the graphic inside a table cell, it can be any node or any scene graph of nodes. So it could be a text field, for example. And so it's a good approach is normally to have one or the other. So you have a label to show the text, and if it becomes editing, you take the label away, you set it to null, and you set the text field to be the graphic. One thing I did around about JavaFX 2 was build a whole bunch of cells. And in 2.2 I was allowed to bring them in. So there's now cell factories for ListView, TreeView, and TableView. And they exist in this package here, the JavaFX scene control cell package. So what that lets you do is create cells a whole heap easier. So you can see here, this is a table view with a progress column. And like I said before, this might be like a download application, for example. And rather than show the user 0 to 100% as numbers, it might be visually slightly more pleasing to show them a progress bar. So the way we do this, the first two lines are as per usual. You create your column, you set the label at the top of the column, you set the cell value factory. In this case, we're just going to pull out the progress number from the backend object. And then we're going to set the cell factory. And what we do is just use a short bit of code. We say we go to the progress bar table cell, and we say this is for a table column. And so this is going to do a whole bunch of code behind the scenes that basically shows what you see on the left-hand side there. And the nice thing about this is that as the numbers go up, because we're binding to it, so as the progress number is changed inside your bean, it would have originally been changing just as a label. Now, because it's a progress bar, of course, it's going to animate across with no actual need for you to do anything more. Yes?
Could you create like a dual control, like it has to go to the backend and fetch data showing the progress bar or something, and then it slaps it like a text or some real data when it's done?
So I might have got your question wrong, but you want to be able to update it from behind the scenes or as a separate thread?
I guess I want to use two different type of cell factories inside of a single cell on a table.
Right. So this is something I would like to do where you can kind of create two cell factories, but it's not something I've done yet. It's kind of clunky. So in many regards, if you want to have a combination of cells, you can actually go to like the progress bar table cell and use that sometimes and another one other times, but you've got to create your own cell factory to kind of switch between them when that makes sense. So just to clarify, there's two concepts. There's a table cell, and then you have to create a cell factory. And the cell factory is basically a callback that's given to the table view or the table column. And the table column it will call that callback when a table cell is needed. So it's basically a callback that returns a table cell. And so basically the progress bar table cell for table column that you see there is creating a callback that on demand will return table cells. And this is normally called at startup. So we create enough cells for the visual area for that height of that table column. But if the user resizes the table column height and we need more cells, the callback will be called more times to create table cells. So another example that's very common is, of course, letting a user type in a text input. And so we do the same two things on the first two rows. This time we're dealing with something slightly different in that we're dealing with sales. And so sales is a number, is a double in fact. It's not a string. So in the last block of code there, we're setting the cell factory to be a text field table cell. And we're saying that this is once again for a table column. But because we're dealing with numbers and the user's typing in as a string, we need to provide a string converter. And the string converter is quite simple. It's got two methods, a from string and a to string. The one we care about really is the from string, so that when the user types in a string, a new number, and they press enter, from string will be called to return a double. However, one thing I did in JavaFX, I think 2.2, maybe 2.1, was I provided a whole bunch of string converters. So rather than write all that code on the previous slide, you just have to write a new number string converter. So my job's trying to make you write as little code as possible.
Automatic error handling?
Sorry, what was that?
What if I enter not a number, then it will have automatic error handling?
So in this case here, you can handle the input. So you can do a from string and you can return an invalid number, -1 or something that your application will understand.
I mean, it would be great if the default cell renderers would catch exception and show some.
So, in terms of validation, and that's basically what the question's about, I've got a meeting on Friday with the Beans validation people, and we're going to be looking into validation over the next few months. It's something that we haven't started looking into yet. It's something I've discussed very briefly on the OpenJFX dev mailing list if you have been part of that. But we're meeting with the Beans validation people to see if we can get proper validation using their approach rather than having to rewrite everything. So another example, just briefly, quite often when you have a table view, some columns represent that the user, for example, is of a full-time employee or a part-time employee, casual or contractor. So oftentimes you just want to present a constrained number of choices. So in this case, what we're doing at the very bottom line is we're creating a cell factory that uses the choice box table cell. And we're saying for the table column, and we pass in the values of the enumeration above, so the employee type values. And because I've created a constructor inside the enumeration, and that's the toString method has been overridden, when it comes out on screen, basically it's pretty printed. So you can see a nice bit full time rather than the ugly uppercase full underscore time. Yes?
Am I correct in remembering we just came out with a combo box code? And if so, do you have a table cell equivalent?
Yes. So there's a table. So for one, I don't know when. I wrote the combo box, but I could swear it came out in 2.1. Prue, do you know? It came out in 2.1, so it's actually been out for quite some time. See, time blurs when you're an API developer. But yeah, so there's also, just like there's a choice box table cell, there's a combo box table cell. And also this also is the same concept for list view and tree view. So
I'm sorry, do you prefer, which would you say we should rather be using in a table choice or combo?
So it comes down entirely to one, your preference, but two, more importantly, is how many options you're presenting to the user. So a choice box is basically a button that when clicked brings up a menu. And the menu is vertically shifted such that the selected item is above the button.
So there's no performance gains in one?
No, there's not, but if you're going to create a choice box with 1,000 choices, it's going to be a menu that is very hard to use. Really, I say 10 or less. Richard the other day said 50 or less. I would say 10 or less, 20 at most, and then go to a combo box. Because a combo box is popping up a list view and you can do all kinds of cool things with a list view. So, someone asked about nested columns, and that's something that, whilst developing the table view, I kind of realized that if I didn't bake it into the very beginning of the table view control, we would have pain later on. So, fortunately, I had that foresight, and we've got nested columns by default inside TableView. So, I'm just going to create a short example. Here we've got a table column that represents, say, the person's bank balance or something. We set the cell value factory as per usual, as a property value factory, taking the balance string. Then what we do is we create a name column, and that's just the first line is as per usual table column with a name text. The next line is the interesting one. So we're getting the columns list from the name column, and we're adding into that the first name column and the last name column. So previously what we did was what you see at the bottom here. We added everything into the columns list of the table view. So what we're basically doing is setting up this nested hierarchy of table columns. And what that takes us from is that what we had earlier on with just first name and last name, or I've got animations, to what we've got on the right hand side there. And hopefully the code that you see, you can see how we got this nested situation going on. And this just can go on as deeply as you want it to go, although I would suggest that if you go in many more levels than 3 levels deep, you might be going too far. And we've got multi-column sorting as well. Sorry, did we have a question? No? Okay. Multi-column sorting. So I'm pretty sure you hold down the Control/Command button whilst you're clicking on the columns to set up multi-column sorting. As you can see there, it's kind of rendered a bit differently. The first sorted column's a dot, the second sorted column's 2 dots, and the third one's 3 dots. I think after that, then it starts using numbers. And if you don't like that, you can always change it. You can replace the sort node for the table columns. The other nice thing about sorting is that the TableView class has a collection of a collection called sort columns, and what that represents is a list of table columns that are the current sort table columns. The first item in that list is the most highly ranked sort column, and as it goes down, they become less and less important. And as the user clicks on these columns, all that's happening is that list has been modified, so that we and the table view is watching that list to be told when to change the sorting. And so if you want to come in programmatically and change the sort order, all you do is you go to that sort columns list and take in or out table columns. Yes?
So you can have a custom comparator or?
So each table column has a comparator property. So you can set the comparator on the table column. It's been a long time since I wrote that, so don't quote me on that.
And are you deriving what the data is to get the right comparator versus text versus numbers?
I would honestly have to dive into the code to have a look. I wrote this pre-2.0, so the question was, are we using it? What are we doing for the comparators? I'm pretty sure we're doing something smart. If by default we're doing something smart, but I'd have to look into the code. And by all means, come on up and we can have a look. But it's also an OpenJFX dev, so everything that I do and my teammates do is open source. You can find all on OpenJFX dev. All right, I wanted to talk a bit about hacks. I'm not too sure what the time is, so we'll just keep going. I'm racing through this so that we've got time for questions later on. And what hacks could we talk about? And I get a lot of emails, I get a lot of Twitter messages, I get a lot of OTN forum questions, and by far the most common is complaints that I just see whiz by on Twitter. So I kind of came up with a bit of a list of things that I've seen people talk about. So we could talk about TreeTableView self-spanning, having a TableView factory. So what these are, so I hope everyone knows what a TreeTableView is. If not, we're going to talk about that shortly. I hope people know what self-spanning is, otherwise we'll talk about that shortly. Other things that we could have talked about were TableView Factory, which is basically an API that will introspect a bean and provide you with table columns based on the properties it finds inside that bean. Having a table model, which is something I borrowed from Jide, David somewhere in the room. Being able to customize a table menu, which is something that, the menu is something that appears in the top right-hand corner, so it appears above the scroll bars. And there's a whole bunch of customizing the scrolling. So one of them is removing that empty column that everyone complains to me about. It's going to dog me forever, that thing. But like I say, I'm going to talk about the first two, but I'm incredibly sorry. I wish they would just give me a 5-hour slot and I will talk to you guys forever. This is my bread and butter. This is what I do every day. I've got a whole bunch of stuff. I don't know how many of you know that there's an FX Experience website. This is one of the websites that I run along with Jasper and Richard. And I'll try to get as many things up there as possible. There are some things up there already, but they're quite old. One of them is like removing the alternate highlighting and various other things. And I'll try my best to blog about them. But you wouldn't believe how hard Oracle work us. I see some smiling faces from Oracle employees in the room. So, first question is, all right, so I'm going to talk about TreeTableView and self-spanning. If someone could tell me the time, that would be great. 3:30? Okay, great. So what is a TreeTableView? And this is a TreeTableView. You'll see that it's obviously been rendered in JavaFX, because I do have a demo to show. And it's basically, surprise, surprise, it's a tree with a table bolted on. Or it's a table with a tree bolted on, depending on your philosophical points of view. But basically, in my point of view, it's a table view with indentation for tree-like features on the left-hand side, and obviously expand and collapse. And what you actually see there is a screenshot of my tree table control browsing my file system. So I hope there's nothing too embarrassing there. So, what an ugly name, TreeTableView. I hate it. It probably will be released as that, because we can't really start calling things tree tables when we've got TableView, ListView, and TreeView. So I'm sorry for that, but maybe I'm the only one offended. So TreeTableView exists. Quick hack, proof of concept on my machine. Slightly better on my machine, but there is an older version on JavaFX 8 developer previews. I promise I will break that API. I've already broken it on my machine. And it may even ship in JavaFX 8, but I'm not making any promises because my boss has piled on the work. This is a Jira issue you want to go to, especially the last bit, RT17288, if you want to partake in this discussion. It's the second most highly voted issue or feature request on Jira. The only one above it, the last time I looked, which was a month or two ago, was Android support, but I'm not going to talk about that today. So, how do you make a tree table view? And my point of view is, the less new API people have to learn, the better. So what I've done in my version, and it's your version if you download JavaFX 8, is I've taken the tree item API, and I've taken the table column API, and in most places I've smashed it together. And then on the implementation slide, I've smashed it together even more. So what's good about TreeTableView? A tree view describes a hierarchy of data, and does that using the tree item API. And so tree view has a root node, and the root node is a tree item. And the tree item has a value and has children. And those children are further tree items. So you have this kind of, you can see there, there's basically a hierarchy being built of tree items. And what's good about a table view is, of course, the table columns. And that's exactly what we need for a tree table view. So we reuse the table column API at the moment. And basically the table column is being used exactly as it is already. It's being used to ask how do we extract the information out of these tree items for every row that's visible to the user. And so what I've done at the moment is TreeTableView extends from TreeView. Don't complain, I'm going to cross it out in a second. All it does at the moment is add a columns list, just like in TableView has got a columns list for you to put the columns into. So it's very, very similar. Tree table column extends from table column. It doesn't add any API. It's just there to kind of signify. It does modify the generic type slightly, but I won't get into that unless someone's got a question. And then we create a tree table row, and then it extends from table row. So what you're kind of seeing is that we're basically merging these two things together. And in the case of this tree table row, we've extended the table row and we've smashed in the tree cell. This is all very, very ugly. So it works. It's a really nice quick proof of concept hack, and it works nicely. The JavaFX 8 developer preview has exactly this approach, but I've crossed them all out because you start ending up with these situations. For example, the tree table view shouldn't really be offering a cell factory that returns tree cells, and that's what it will get if it extends from tree view. Nor should the tree table column or the tree table row be referring to table columns, because table column is entirely separate, table view is entirely separate from a tree table view. So we get the situation where we've got this API that has to be null because there's nothing to put inside it. So my current thinking is we have to get rid of that. We might have to do some code duplication. Hopefully we'll get a tree table view at the end, and that's the main thing. And on the private, back-end side, we've got this tree table view skin. And basically, all it does, for people not familiar with the controls, we're going to do a whole bunch of talks tomorrow about it. Pro and I have a talk, and Garrett Grunwald has a talk as well, so check those out. But basically, a control has a visual representation, that's the skin. And all we do in the tree table view skin case is we throw in a table view and we make it take up the full size. And the other thing that we need to do is, obviously a tree table view has tree items, and we need to map those somehow into a list so that the table view can obviously show that. So what I've basically done is just hacked a bit of a list that when get is called on an index, we return the right tree item from the view, and the size is obviously accurate based on the current expansion. Basically, one of my jobs is to make things fast as well, so that's extremely fast. Tree table row skin is a very ugly class at the moment, and the source code is probably out there if you can get the 8.0 repos. I'm not sure they're out yet. And it's just those two classes merged together. So it lays out all the table cells, but the first column is a bit special in the tree table view because it has to have the indentation on the left-hand side, but the column can't extend past the width of the header. So it's kind of shrunk, and it's just deal with that. Yes, so on my machine, this one here, so don't steal it, is a lot of work to extract out the common functionality. I don't know how well it's going to go, but hopefully I'll have some time to do it. So I'd be interested to know if anyone has any complaints, if they think I should totally rewrite everything I've done. Everyone think it's okay? Cool. Sorry? Filtering? So this would, yes, so the intent is probably to have tree table column offer better filtering API and sorting API, because certainly in the case of sorting, when you're sorting a tree-like structure, sometimes you just want to sort the children, sometimes you want to sort higher up. So certainly there has been some discussion on that Jarrett issue that I linked to earlier on about how to do that, and chances are, my opinion at the moment is that we will do it on the tree table column class, because yes, then you can specify things, how to filter and sort a column in the right place. Okie doke. So I have to apologize. My machine's incredibly low resolution. For some reason. It's Windows 8. It's all Windows 8 fault. Oops. So this is the TreeTableView, sorry. This is my file system. We can go into program files. Oops, it's gone up. So we can see what I've got installed on my machine. So it's basically what you would expect. Thanks, buddy. It's what you can expect. It's a table view and a tree view. So if we resize the size, oops, if I, it's crashing. My whole machine's crashing. Here we go, all right. So you can see the sort's changed. Probably this makes more sense. Oops. So it works as you would expect, basically.
So it's still honoring that kind of just blew my mind a little bit compared to the old Swing version, where the one column had like the branches and leaves, and it was always, the rows were based on the parent nodes and branches. But let me try to say this. So you move size over, and then and so size and name swap, for example, right? But then I wasn't expecting the expandable things to stay on the left-hand side per se.
Okay, you expect them to stay with the name column.
Yeah. So how is it knowing which row?
Well, I mean, right, so counting table columns 0, 1, 2. If we're on the 0th column, we're going to put the arrows in. And that's basically all I've done. If that would, I mean, I've implemented this. User experience haven't spoken up. Testing haven't spoken up. My boss doesn't know it's in there. I hope it's not in the room. This is how I would do it. There's a long road from where I would do things to how I might end up. This is how I would like.
It's wrong. Not by a long shot. It's cool. It's
Yeah.
just, I just didn't know how it's keeping the expansion groupings, I guess.
Okay. Certainly this is my preference. Sorry, big plus one. Oh. Yep.
But how do you decide what the root node or the grouping node name and size is? If you expand one of those, is it because everything belongs to the same document? Like, expand them.
Backup. Oh, there's nothing in my backup folder. I'm pretty bad at that, sorry. Eclipse.
Yes. So if you expand this one.
Sorry, my machine's going very slow for some reason. There we go. Oop. Yeah, there we go. All right, Eclipse.
So, okay, so you're not grouping them by date. The nodes are just over the side. Okay.
So basically, tree item, just like in TreeView, tree item knows the expanded or collapsed state. So it's the tree item that's recording that the Eclipse folder, which happens to have a modified data of this and size, that's irrelevant. It's just that the tree item is expanded. Sure.
What kind of selection model do you have, and does it survive changes in
Right.
this model? And how?
So the question was, what kind of selection models do we have, and does it survive changes to the data model? The answer is, for TreeView, ListView, and TableView, we have a multiple selection model. That's the API that we have. And the multiple selection model obviously lets you specify whether something should, the selection model should be single or multiple. It also lets you specify whether it should be row-based or cell-based. So that's the selection model that we have for list, tree, and table. And same with TreeTable, because it's just a table view basically. In terms of surviving changes, the intention is yes, although every time we don't have a release out, like now, like with JavaFX 8, everything breaks because we're working on the next release. So at the moment, I mean, if you look at this, and I hope my machine, something's going slow on my machine. But at the moment, it pops down. When you expand, the selection pops down. And that's just because I'm hacking things at the moment. But certainly the intention is if the data model changes, the selection will update to know where the selection should be. Yes, Carl?
At some point, will you have styling with a collapse? And sometimes it's hard to see the indentation.
All right, so everyone's styling. So certainly we expose everything via CSS, so you can style how things look. You can also specify, in the case of the tree view and the tree table column, the amount of indentation. So I think it's about 10 pixels, which is on this very small side. You can easily make that 20 or 30 pixels, and then things jut out far more obviously.
But can you put lines?
All right, so sure. I mean, all that we're doing basically is showing, so the arrow is just what we call a disclosure node, and the arrow is specified in CSS. So if you want to put lines in, what you're basically going to do is have lines go to the top of the row and the bottom of the row such that they are in the right place. And you're going to do that via CSS and with SVG shapes. Yes?
Yeah, for some of the stuff, I find that the whole thing is a bit disturbing where you're collapsing and expanding to the straight column. Is there a way to lock columns? If I wanted to lock the name on the left-hand side, nothing would be ever moved to the left.
So this is one of the feature requests I've had for a very long time. So freezing columns.
Right, the same thing would apply for a table.
Right, exactly. And it's something I've had for a very long time. It's just something I haven't got around to yet. I think Tom may have asked me for that feature. So no, it's not something we have yet. Certainly it's on my to-do list, but my to-do list is exceedingly long. Yes?
Can we temporarily work around that by listening to like table columns and increment or
Yes,
something like that?
basically. That would be the best approach for now. Because you've got this columns list, you can observe the columns list, and as the columns change, you will be notified if you add a listener. And if you don't like the order, you can change it to something else. Right, so if you don't mind, I'll carry on. No more questions? Yes? Sorry, can you speak up? There's a TableView component. Yep. So this is the philosophical difference I was speaking about earlier on. My intent for doing it this way was so that we have API that's entirely consistent. In fact, that file system browser that's in the TreeTableView was taken from my TreeView sample. That I can browse my file system in TreeView. I took the code that creates the hierarchy for my file system, and I put some table columns in that specified the name, the last modified day, and the size, and it just smashed together really nicely. So that was the intent, to try to make it so that was easy to do. Unfortunately, like I said earlier on in my slides, I don't know that that's going to survive because it ends up with some kludgy API. We're slowly running out of time, but the next thing I want to talk about was cell spanning. So what is cell spanning? And this is a trick picture because it doesn't have any cell spanning in it. This is a normal table view. Conversely, this is a table view that has the every third row has the middle column spanning 2 rows. So you can see there what that looks like. Conversely, you can have column spanning, where in this case every third row spans 2 rows. The first column spans spans 2 columns. Or you can have column and row spanning, where it happens in both directions. Cell spanning was something I ignored in TableView for JavaFX 2.0, and it came down to the classic: too much work, not enough time. And I also argued that there was a philosophical difference between a database table and a spreadsheet table. And what I was building was a database table. So there are differences, if you can imagine how they kind of work. A database table does not span rows or columns. It shows the data precisely the way the table view shows it now. Am I hearing an objection?
Yeah.
Okay. Well, I'm naive, but it turns out it's actually quite simple to create a table view that supports cell spanning, which is why those pictures that you saw previously exist. And if you're interested in joining this discussion, this is the Jira to go to. It's RT24747. The big problem I had was always, when I was trying to think how would I do cell spanning as the user of the API, how would I tell the table view where the span should appear? And if you think about it, there's not a clear answer, to me anyway, unless you separate the data from the spanning. And unfortunately, that's the way I've gone. I follow the direction of the GIDE table view control that supports this. So I introduced the span model. And that's the API there. And it's very simple. It might change, of course. This is not anything we're committing to. And it says, Is the self span enabled, true or false? If it's true, then we're going to start caring about what the other method says. Otherwise, we're just going to go on as per usual. The second method returns a self span object, which I'll cover shortly. And basically, we get the self span at a given row index and column index. And I'll go through this in a bit more detail shortly. So self span is very simple. It's a final class, two fields. It's the row span and the column span. And if you think about when you're talking about self span and it spans one column, that means it's spanning just the column that it would have done anyway. If it spans two columns, then it's going to span that one and the one next to it. And same with rows. So one means don't span anything more than usual. So how would you use this? In my case, what you have is a self span TableView class that basically extends from TableView, adds in the span model. And what you do is you set the span model on it, and of course you make this self span enabled return true. And the way I do it is I start creating these self spans. And so this one spans 2 rows. And then you put your logic inside the get self span at method. So if the row index is cleanly divisible by 3, and we're in the first column, so the second column, span 2 rows. Otherwise, return null, which basically means don't span anything. And the end result is what you see here. You can see the middle column, the last name column, this cells that span 2 rows.
Does that carry across if you were column?
Sure. So the count is from the table columns. So regardless of if you're scrolling horizontally, it's from the table columns. So again, I'm interested to hear people's thoughts. This is not something we've committed to in the least for 8. Chances are my boss will reject it for a long while, but it's very easy to make an open source project out of this. So I'll probably do that. And in fact, I'm trying to start up a JavaFX Labs project, much like Swing Labs. So more news on that soon, hopefully. Yes.
The last slide you just showed, can it also be used with like beam properties and so forth? Does it have to actually be index values themselves? Can I say about the last name column I wanted this versus column change values?
So the question is, can you use table column instances rather than the index, or?
Maybe I'm getting hung up in Swing where you have like a model and a view that backs and
right.
stuff like that. And so I like to do row-based. I use properties of what's being displayed versus index
right.
values. Maybe it's not needed here.
Honestly, this is a quick hack. So I'm certainly open to any suggestions on how this can be made better.
That would be one. If we could
yep.
do it not by index value.
So if you know, there's a Jira issue. It's been very quiet because I just started it very recently. Certainly, I would entertain. I suggest people go there and.
If you get a chance to go back to that slide, so I have enough time to write it down. I'll be looking for posts there.
Yeah, 24747. Any other comments on self spanning?
Which cell renderer has it called?
Okay, so. Now there's a difference between cell spanning and cell merging. I had to search Wikipedia the other day to learn what the difference is. But the difference is that cell spanning, which is what I've done, takes it such that the cell, for example, when we're looking at bond, which is the first spanned cell in the middle row, bond is taken from the top row, and the row beneath it, but it starts billy, that middle column just doesn't exist. So self-spanning means you take it from the point of origin, which is, in this case, bond. Cell merging means you kind of cludge them together and you'll get bond and whatever is belonging to Billy. All right, so, okay, carry on. Okay, do a quick demo because I'm running low on time. All right, so this is a standard table view. This is one with row spanning. So you can see I can click here to get that or there to get that. So it's as you would expect. Keyboard navigation works as you would expect. It goes row by row. We can do cell-based as well.
Can you edit a cell instance?
Sure. I mean, I haven't done that, but there's no reason why not. The cell, if we say we were to show a text field, cells are always expanded to fill the entire area. So in case of bond again, a text field would probably be expanded to fill the whole area unless you clamped the maximum size so it doesn't grow. Column spanning, same thing. So Jenny is the first name, so it belongs to this one up here, and this person here is entirely wiped out. So I am really bad at demos. I just found a data set and threw it into my demos, okay? So this is really bad. This makes no sense. I'm fully aware of this. But for the sake of a demo, it makes sense. You know, I like to write code. I don't really like to write demos. So you can see it works as you would expect. All right.
Do you see any issues with multiple row column headers in expanding cells?
No, not really. I mean, the thing is, with multiple, nested columns, it's actually just a graphical thing. Like everything other than the very leaf set of table columns is just a nice kind of visual thing. It doesn't impact anything. You can't sort on those. You can rearrange on those, but you're going to take all the children with it. So no, I see no problem with that. Like I said earlier on, I needed to do it in TableView to get nested columns from the beginning. Otherwise, the API changes quite significantly, and I probably couldn't have done it very cleanly. All right, I'm running low on time, so I might just quickly go through this. So I created some API, cell span TableView, span model, cell span. The way I did it, and this is the same with the tree view as well as the cell spanning, is I took the table row skin and I hacked it to do stuff. So in the case of the tree table view, the table row skin put in the indent and shrunk down the first column. In the case of cell spanning, it basically modifies how the cells are laid out such that they're spanning correctly. And to make this happen, basically I threw in a bit of CSS where for every cell span table view that's created, and for every table row that's created that belongs to a cell span table view, use the cell span table row skin rather than the default table row skin. So it's just a bit of CSS that lets me replace the skin. So all the hard work was handled by the cell span table row skin. All I did, like I say, was override or modify the layout children class. And the layout children class is totally responsible for how the children are painted. So here's my graphics. Pretty good graphics, I think. So a table view is laid out table row by table row. And each table row is laid out column by column. So you kind of get this kind of thing going on when you lay out a table view. And now, some of you might be thinking, if I have row spanning and say a cell spans 3 rows, isn't the rows that are going to be painted next just going to paint over it? And of course the answer is true. So there's a little bit of hacking going on there with making things transparent and picking on different bounds and all that. But the end result is that you get the result that we want. So here's a very simple diagram. Basically, as we're going cell by cell, we kind of look at it and we go, what do you want to be? Get the cell span at this index, and then we can lay out things. So this previous one obviously wants to be 2 columns wide. So we ask it that, and it tells us I want to be 2 columns wide. So we get the width of that column and the next column. And then we move on to the next column, start laying things out. Turns out the next column actually wants to span 2 rows. So we lay out all the other cells, and they're all as per usual. Everything's just normal. And so the next thing we do is we realize, actually, we've just got a cell already there. We don't want to lay something else on top of it. So we just jump over it. We just ignore the content that should be in there. And of course, it makes us lighter. If we have a cell that spans the entire width and height of the table view, we're only going to have 1 cell. And then everything else is happy. So that took me so long, so I hope you appreciated that. You wouldn't believe how hard that was. But anyway, that is everything I wanted to say. So thank you very much for attending. I hope you've got plenty of questions. Feel free to email me at jonathan.giles@oracle.com or on Twitter @jonathangiles. Thank you very much.